Here we are. Everybody receive the documents? Okay, so why do we study statistics? What is the point of statistics? I'll ask you the first question. What is a statistic? Give me a definition of a statistic and an example. So I'm speaking in general terms, and then I'm going to spend next week focusing on finance, obviously. Okay, I only see a few people watching right now. So that means that the students will have to watch this video later or use their knowledge of statistics if they don't. But we're going to fly through it next week, so it's really important that you do this review. So what is a statistic? A statistic is, or an example would be average GPA of students in their fourth year. An example could be the median income of households in San Juan metro area. A statistic is a number calculated from data in a sample. That's what a statistic is. That's the most general explanation I have. With what purpose? Why do we do this? The idea is that the statistic A statistic is a number computed from data in a sample. The idea is that I can, in a cost-effective way, I guess, gather a sample and learn or gain information about that characteristic that I'm measuring. So if I'm measuring student performance, something like a GPA would be an indicator of student performance. Very good, Daviana. So a statistic is a number computed from data in a sample. And what is its intention? That's the whole thing. What is the intention of the statistic? Why do we do this? Well, because we believe there's a population of data out there that our sample aims to represent. And that population has characteristics. So if it's students, it has certain characteristics, and we want to know their abilities or their performance. We want to capture that, but population usually is difficult to acquire. Like all of the data, all of the information available is difficult to acquire. Now, something like an institution like the UPR, you could probably get all the information on student, so that you could do that and actually calculate the GPA of all students. But it all depends on the ability, the record keeping, and the collection of all that information. It does cost money to keep, house, and update all that information routinely. So when we think about this, we want to think more general about populations we cannot get all the information on. So something like learning about all individuals' income in the metro area of San Juan, that might be difficult because people might not be documented, people might be homeless, people might not be traceable for whatever reason, or they don't respond to calls or communication. So it's hard to get it's hard to get all the data on the population. So instead, the second best thing to do is to collect a sample. From that sample, we can calculate statistics based on the data in the sample, and the statistic aims to estimate the parameters of the population. A parameter is a number computed from data in a population. Now, whether a statistic is a good estimate of a parameter depends on a number of things, and one of those is how good the sample is, how representative it is of the population. Okay, so to remember this terminology, parameter starts with a P, and population starts with a P, and statistics starts with an S, and sample starts with an S. I'm saying this because people use the term parameter quite loosely, and it's very specific in statistics. It's referring to the possibly unknown characteristic of a variable. Okay, and so that's what the word statistic is used. The statistic is meant to estimate the parameter. So the parameter is really our goal. How many of you knew that? I think muestra, you say muestra in Spanish, but other words, otherwise, I think you still say población. Parameter is probably something like parameter, and a statistic is estadística. So there's a variety of different kinds of statistics, and the ones that are really important to us are the sample mean, the sample mean, it means to estimate mu, the population mean. Mu is a parameter. S, the sample standard deviation, aims to estimate the true or population standard deviation. Okay, and some other statistics I'll discuss, although in finance, at least in this course, we focus on the mean and standard deviation, so those are mostly it. But you know about also the alternative to the mean is the median, or I'll call it the sample median. This is also known as the 50th percentile, and we'll talk about percentiles. It's the middle observation if you order data. So the sample median should estimate the population median. So I don't know, there's not a really standard. So these symbols I've printed here are standards, universal standards. Sample mean is x bar, population mean is mu. This is the Greek letter M for mean. And S is the sample standard deviation symbol, where sigma is the Greek letter S, lowercase s, for population standard deviation. And there's no real standard for the median. We just use M, and it's an estimate. I don't know. I don't really want to write this, but you know, I don't know. That's just another example. I'm not going to put a symbol in. That's what I'll do. I'll avoid it by just no symbols. So the sample median is another example, and the population median would be what it's trying to estimate. Okay, so those are examples. And one more that's popular and that you've learned about is proportion. Proportion is really important. Proportion of people who wear masks in public places, a proportion of people who vote Democrat, something like that. So proportion, sample proportion is one you learn about. And it estimates the population proportion. And these symbols are also rather standard. So I put a hat on the sample one and to indicate it's different from the true one. Okay? So, having said all of that, these in the sample are meant to estimate these in the population. So what is the goal of statistics? The goal of statistics is to gain information from data about a variable so that we can better understand what to expect. And I'm going to add in as a goal to alleviate uncertainty. Statistics is instrumental in dealing with people's anxiety, giving them some answers. People want answers. And statistics do that. They give you some sense of what's going to happen in relative proportion. You know, this is more likely to happen in that than that, etc. Okay, so it allows for decision making. So any characteristic of a person or thing that can be expressed as a number is called a variable. So dollar sales, quantity demanded, interest rates, those are all variables. The value of a variable is the actual number that describes the person or the thing. When we have data, we like to display the data first in a graphical representation, and that graph reveals what values the variable takes and how often it takes those values. And this is for a sample, or even if we have all the population data, we would do something like this. So we need to first graphically represent the data, and then based on the graphical representation, we decide what statistics to use. And I'll give you an example. And here are my definitions that I just described. Okay, so I've said all of this here already. All right, so where I'm going to start is an example. Here's my example. This is the data that has been ranked and arranged demonstrating how much shoppers spend in a store. So you can answer the question how much shoppers spend in a store by summarizing what is seen in this graph. This is known as a stem and leaf or a split stem and leaf graph. This is the first digit and this is the second digit. And I put all the data here. And I've rounded, just assume this is all the data, and they've been rounded to integer values. The second question we want to answer is how can the data help improve the store's marketing strategy? So when we look at this data, are you okay with what I've put here? So the data here has been put with a stem and a leaf. And the reason why there are 2 digits is because the data in order is $2, $7, $7, $8, etc. all the way to 69. Now because the last one in the ordered data set, it has 2 digits, they all need to have 2 digits. So I put a 0 in front of the single digit numbers. So what we do now that we have displayed the data is we need to summarize it. And we begin summarizing by smoothing out this curve here. Now I could say that I think that if I had more data, I believe that there will still appear 3 groups of shoppers. This is a group of shoppers that spend a low amount or a low amount of money. There's the middle group that spends a middle amount of money or medium amount of money, and then there's the high spenders here. The more they spend, the less shoppers there are that spend that much. You could think that, or you could think that I think that if there was more data, I believe it would just be like this, that this gap would fill in and there would just be one group of people here and then this group that spends a lot. So depending on what, maybe once you do the analysis and think about it a little bit, you can decide if it's the gray curve or the yellow curve. What I'm talking about, these are density curves. Density curves is an idealized version of the distribution. As if you had all the data, what you expect to see. Okay, now you could be wrong, but based on what you have to date, you have to make a statement. And what I'm going to do is I'm going to stick with this version because I have a story to tell about the gray option. Let me do it again. So I'm going to fix this and just pick the gray one with the 3 groups in it. Now I've divided the data in equal intervals of 5 . Okay, I like the 3 groups. So these are equal intervals, and this one includes the values from 0, 0 to 0 to 0, 4. So there's 5 possible numbers in there. And the next one starts 0, 5 to 0, 9, and then 10 to 14. So this way, each of the classes, that's what these are the classes, are mutually exclusive. So when I look at this data, I want to make some statements, some summary. And the way I do that is I use the 5 features. The 5 features include first, shape. The shape of this distribution is asymmetrical. It's not symmetric. A symmetric distribution is what we're going to focus on soon, but this is known as a right-skewed distribution. It's characterized as, I'm going to turn this on its side. So we usually look at them like this, right? As a number line on this axis, going from small numbers to large numbers. And a right-skewed distribution has just a few observations in the extreme, but most of the observations below. And when a distribution is right-skewed, it influences, or skewed in general, it influences our measure of center and spread. The statistics we use to measure the expected value, or the center, will differ than if the distribution was symmetric. What is the expected value for skewed data? Which value would you depend on, or which value would you predict would be the spending of the next shopper walking into the grocery store? What single number would you think would be the amount spent by the next shopper? What number would you compute to capture that? Well, it turns out that whereas Most of the time, people will say just calculate the average as the expected value. That doesn't work for data that are skewed. Right, Daniel says propose the mean, but that doesn't work for data that are skewed. That's described here in the notes. So what is the mean? The mean, you can remember this drawing or you can remember this sentiment. The mean is the value closest to all the other data, closest to all the other points. In that sense, it's the center of gravity. The mean is the value closest to all the other points. Now, it might not be the one of the values or one of the observations, but it's in the middle and it's closest to all of them. So it sits so that it balances the density on one side from the density on the other. You see? So it's closest in that sense. It balances the distribution. So the problem with that, I mean, that's great, it's the center of gravity, but in terms of, so that relates one value to all the other values. But in terms of making a guess, if you pick the mean, that is, notice it's moved away from most of the clump of data here, and it's pulled towards just a few values over here. And that's problematic because there's only a few over here, and there's way more over here. So it's more likely that the observation, the next person coming in, will be in this group than way over here. So how do we adjust for that? We have a different measure for that, and that's called the median. So the median is useful because the median doesn't include all the values. The median is computed as the middle value of the ordered data set, or the average of 2 in the middle. Since this data has 50 observations, is an even number, there will be 2 observations in the middle. And I'm not going to get into that so much because I'm not going to teach about the median, but you need to know the difference. Okay, you need to know the difference. So for expected value, we don't use the mean, we use the median. Let me say something more about this as well. So here we have the different shapes, right? So which shape, we're this one, we're right skewed. And in the right skewed distribution, it's different than the symmetric one. The symmetric one is in the middle here. For the symmetric distribution, the balancing point is here, right, on A. So the mean is in the class at A. It's in that group. It's one of those numbers in there. So you got to remember, I haven't put the data in here, but you could, okay? So the mean is there. Also, here is the mode, the modal class. It's the most frequent observations occur. The most frequent class is this middle one. So this middle is mirrored on the right and on the left. And it says that most of the values are at A. Some are higher, but just as many are just a bit lower. And some are much higher, but just as many are that much lower. So it balances out on either sides. And what you expect if you were to bet is that observations would occur around here, very, very close to the middle. And your best guess would be the mean. It turns out that also in the middle is the middle observation, of course. So if you were to put all the numbers in order, you could find the one in the middle, and that would be the median. So it turns out in symmetric data, the mean, median, and mode are all basically the same. Having said that, the convention in statistics and economics and finance is when data are symmetric, we just use the mean. Okay? We only use the mean. Statistical software will report the mode and the median, and you can still calculate them, but in analysis and discussion, in computations, the mean gets used primarily. That leaves the mode as an important descriptive value, because it tells you, you can see it on any graph, and a graph is always what you do first. In any graph, you see it right away. It's where the peak is, or any of the peaks, because you could have more peaks. You could have more peaks than one. So you see the mode. So it's important that we can see the mode and to talk about it. But you should also now, since you've taken statistics, most of you, and now you're doing this class, you should also be able to see the mean and the median. The mean will be the measure that's closer to the tail. It will be pulled towards the tail because every single value goes into calculating the mean, and that pulls the mean towards it, away from the greater majority of the data. So the mean is closer to the tail. If it's a right skewed distribution, the mean will be closer to it. If it's a left skewed, the mean will still be closer to the tail on the left. And in the middle, you will always find the compromise, the median. The median will be in the middle. Or if it's an even amount of observations, it'll be the average of the two in the middle. It's the middle observation. So some examples, for symmetric distribution, many physical phenomena are symmetric, like height and weight. Scores on standardized tests, those are all symmetric. Right skewed distributions are income. So if you ever hear about income, household income measures, they will be right skewed, because there's the 1% people talk about, the few very rich people that skew the distribution to the right. So when reporting on income, the median should be reported, not the mean. You need to check first, though. You need to check your distribution and then pick median rather than mean. For left skewed distribution, this is where most of the observations are high, just a few low ones. That could be possible too. I use the example of school grade completed. Most people have at least a grade 9 or 10. Many have more than that. And in terms of school grade, kindergarten to grade 12, there's very few people with no education. But they skew our distribution. So that's about the mean measures. There's other measures that we're going to talk about in the coming unit. And another measure in finance that we use is the geometric mean. The geometric mean is calculated by a multiple of values. So you multiply them, and because you multiply them, then you have to take the nth root to find the average of that multiplication. So it's done like this. Now you've seen this before, but you've seen it more like this, right? You've seen that we can put rates together, factors of accumulation, and calculate the average among those, minus 1. So we're going to talk about this when we have different rates over time. If you wanted to know the return on an investment after 1 year with one rate, but then the rate changes, then this would be after 2 years with a different rate up to T different years with T different rates. This would be the accumulation over that period, the holding period of that investment. And you could calculate the average by multiplying those and taking the Tth root. So we're going to talk about this. This is a geometric average return. And what's really important about this is that this kind of way of measuring the average is it's resistant to outliers. It's resistant to extreme values. It's like a median in that way. And I'll show you, we'll see an example of that next week. All right, so I've kept you guys quite late. I will pick up this review tomorrow, and you have all the notes. Hopefully I can do it in an hour and a half, because tomorrow I need to go somewhere at 10:30. So we're only going to have class till 10:30 tomorrow, all right? And then if you have any questions, you're going to have to contact me in preparation for the test. But I will email you all the solutions. We're going to finish with the review over the next day or so. And next week, I really want to start into risk and return and looking at, since now we figured out how to make a projection of cash flows, the next step is to figure out how to compute an appropriate risk-adjusted rate of return. So you guys have a good day. See you tomorrow, and then good luck on your test preparation. Okay? Take care.